AP Chemistry, this is the day 1314, lesson 1314, stoichiometry grams 2. So we're now on problem 2. What we have is a combustion reaction. It's one of the 5 basic reactions that you'll learn later. It's any kind of hydrocarbon, a CH compound, plus oxygen. You light a match to it, it burns, and it produces carbon dioxide and H2O. The only difference between them is the hydrocarbon. They all combust with oxygen, produce carbon dioxide and water. The only difference is the hydrocarbon and how it's balanced. Different hydrocarbons balance differently. All right, so in this one, I'm asking you to compute the molar masses. So I'll do it thoroughly in this example, and then in later examples, you'll know how to do it. You can do it. Okay, so first we're going to start with CH2. Let me say that C2H4. Correct that. Not CH2, C2H4 is correct. Okay, so carbon, hydrogen. You have 2 carbon. Get your periodic table. Each one is 12.01. We're thinking of that as moles of carbon now, not just grams individual. So it's not just molecules or atoms. So it's 12.01 grams of carbon. And you multiply that to extend that out. Hydrogen, we have 4 of those. Periodic table says 1.01. And now we add them. And excuse me, if you saw my math mistake there, that was a 2. Because I knew that wasn't going to give me the total that I'm used to seeing. So that's going to be a 6, a 0, and a 28. Okay, so we can write that right here. Right there. Next. Now, don't make this mistake. It's not 3O2. It's only 1. You want 1 mole of O2, not 3. The 3 applies to whenever you're doing the problem and you're relating any of these, the O2, to one of these others. But for molar mass, it's always 1 mole. So your periodic table says that an oxygen is 16 and you have 2 of them in an O2. And there it is for oxygen. CO2. Add those and you get 44.01. You'll have some of these memorized fairly soon. Okay? And after each of these, I should write the substance. Let's go back and do that. Unit of measure in substance. Just get in that habit. Okay, and let's see, we'll do H2O here. Okay, there they all are, so we can go ahead and write them up here. This is 32. Just have to squeeze it in there. All right, now we're ready to start the problem, and we're going to use our graphic organizer again. So use it, the first few problems, use it as long as you need to use it, but eventually you want to kind of get yourself off of using it, all right? So again, we can measure things in grams. The chemical equation works in numbers of particles. You need 3 oxygen molecules for every 1 ethylene. Again, I like to write the coefficients there so you see that that's definitely 3 to 1. See that relationship. All right, and this is how much it will produce. So it's numbers of particles, not weight. But we don't have any way to count these numbers, so we use weight through this magical relationship called molar mass. We use weight to figure out number of particles that we're going to need in our equation. Once we've solved for what we want to solve for in the equation, if we need to, we can come back out and get number of grams of some other substance. Okay, so here we go. So how many moles H2O? So there it is, unit of measure and substance, moles H2O. Can be produced by 3 moles of C2H4. So here you have the number and the unit of measure and the substance. So this is your known, this is your unknown. So we're going to come over here. It's moles to moles. That's the easiest one. So we're going to come over here. And what we're trying to find is H2O. Which your known goes over here. It's just MOL for moles. Okay, let's see how many conversions we have. Okay, so we're starting with 3 moles C2H4. So here's C2H4, here's moles right there. And we want to go to moles of H2O. So here's H2O, we're in the moles row, so that's our question mark. So that's a single conversion. You can move sideways inside of the chemical equation, and it's just a moles to moles. And your equivalency, again, is simply whatever the coefficient is and the substance, coefficient and substance. The only thing you have to add is the word moles. It's in the moles row, so add that word. So I'm going to come down here. I'll go ahead and write the equivalency this one time, but normally, you can just accept that that's the equivalency. And conversion factors. Okay, so it's a one conversion, it's one movement across like that. These don't matter, you're skipping over them. So moles to moles, so it's one box. There's our equal sign, okay. So which of these two goes in that box? Hopefully this is kind of making sense to you now. We need moles C2H4 to cancel, so it has to be on the bottom. We need moles of H2O to be on the top here, so it appears in the final answer. So it's going to be this one. Moles of C2H4 cancels there and there, and the last man standing is moles of H2O. So it's simply 3 times 2 divided by 1 is 6. And that's your answer for that. All right. We did this one in class, so you should have it. If you didn't, then I want you to do it on your own. But I kind of helped you out. I did that one. The boldface are supposed to be the ones you do on your own. So I will give you an answer for that one. Okay, and for B, we're going to end up with 11. Here's the answer, 0.5 grams of CO2. Right there. Okay. You do that one. All right. How many grams of O2 is required to produce 8.3 grams of CO2? So by this point, some of you are recognizing if it's grams to grams, it's going to be 3 conversions, okay? So let's go ahead, and that means we're going to have a long equation here. So we're going to do grams of O2. That's what we're looking for. And way over here, we're going to have 8.3 grams of CO2. So we're going to come up to our organizer and clean it up here. Okay, and we're 8.3 grams of CO2. So here's the grams row, here's CO2. So that's 8.3. And we're looking for grams of O2. So here's O2, here's the grams row, so that's our question mark. That's what we're trying to find. So again, even though the chemical reaction is moving from left to right, our math equation is going to move in this direction. It's going to start with what we know and end up with what we don't know. All right, so that's going to be 3 conversions. You're going to use the molar mass of CO2 to get you into moles of CO2, that equivalency there. Then we're going to use the relationship between moles of CO2 and moles of O2 to get us from there to this box. And then we're going to use the molar mass of O2 to get us back out into the grams of O2. So 3-step process. So we'll draw 3 boxes. Okay. So our first one is, again, to go from here to here, use that molar mass. That's your equivalency. The only thing you have to add is the substance CO2. 1 mole CO2 equals 44.01 grams of CO2. So we'll write that down here. We're going to write everything for these first couple problems. Okay, there's our 2 conversion factors based on that equivalency, which again was the molar mass of CO2 right there. Okay. All right, so which one of these 2 goes in the box? You have grams of CO2, doesn't appear in the final answer, grams of CO2, so you got to cancel it. So that's this one, it's going to make it cancel. Grams of CO2 cancels. So you're now sitting in moles of CO2 right here in this box up here. That's where you are right now. Now you need to move from moles of CO2 to moles of O2. There's your equivalency right there. I'll write it out down below. The only thing you have to add is the word moles. 3 moles O2 equals 2 moles CO2. Okay, two conversion factors. One of them goes there. Which one is it of these two? You got moles of CO2. It doesn't appear in the final answer. That means it has to be canceled. So there's moles of CO2 on the bottom. That's the one you want on the bottom. So 3 moles of CO2 cancels with moles of CO2. So now what we have left is moles of O2. So that means right now we're in this box right here. Moles of O2. One more conversion. We need to get from moles of O2, that's a number of particles, into the mass, into its weight. We use the molar mass. 1 mole O2 equals 32 grams of O2. Okay, and I'll be done pretty soon. All right, so okay, so our last conversion, we need to get out of the equation and back into grams here using the molar mass of oxygen, O2. So 1 mole of O2 equals 32 grams of O2. So that's going to be our equivalency. Okay, there are the two conversion factors. Which one goes in this box? So again, you have two ways to recognize it. You have moles of O2 have to cancel because they don't appear in the final answer, and you need grams of O2 to appear on the top for the final answer. So it's going to be the second one right here. Okay, so moles of O2 cancels with moles of O2. The only unit left is grams of O2, which does appear in the final answer. So now you multiply everything on top. 8.3 times 1 times 3 times 32 divided by 44.01 divided by 2 divided by 1, and that gives us just call it 9.1. It rounds up to 9.1. So 9.1 grams of O2 is how much is produced from 8.3 grams of CO2, or the other way around. 8.3 grams of CO2 is produced from 9.1 grams of O2. All right. We're going to keep moving on here. All right, how many moles of O2 are required to make 12.52 grams of H2O? So what we're looking for, units of measure in substance, is moles of O2. So you're going to come way over to the right, and it's moles of O2. And you're starting with this, 12.52. Okay. Now, some of you can just look at that and know how many conversions, but let's do it on our organizer here. So I'm going to clean it up. Okay, again, you don't erase the molar mass conversions. You're going to use those throughout the problem. Just some of these arrows and circles I drew, I'm getting rid of. Okay, so here we go. So it's 12.5 grams of H2O. So I come over to H2O, go down to grams, and write 12.52, and we're trying to get to moles of O2. So here's O2, and here's the moles row, so the question mark is there. We need to get from here to here. Again, you can only move sideways up in the equation, so you come up using the molar mass of water to get to here. And then you use this relationship between H2O and O2 to get from here to here, and that's it. You're at your final destination. That's your answer. So it's two conversions. So we're going to come down here and draw two boxes. Okay. So the first conversion is going to be molar mass. So there is your equivalency right there. 1 mole H2O equals 18.02 grams of H2O. So I'm just going to go ahead and write the conversions down below. All right, there's two conversion factors. Which one is going to go in the first box? You need grams of H2O to cancel, so you're going to use the one that has grams of H2O on the bottom. Okay, grams of H2O cancels and cancels. You now have moles of H2O. That means you're sitting in this box right here in the H2O in the moles row. Now you're going to need to get from moles of H2O to moles of O2. There's the relationship. You just set an equal sign in between those two. So it's going to be, I'll go ahead and write the equivalency. Okay, you just have to add the word moles and then the conversion factors. Okay, here's your two conversion factors. Which one goes there? You need moles of H2O to cancel, and you need moles of O2 to appear on the top, so it's going to be this one. Okay, so moles of H2O cancels there, and there you have moles of O2 for your final answer. So it's going to be 12.52 times 1 times 3 divided by 18.02 divided by 2, and that gives us 1.04. I'll just go ahead and put it out there. 1.04 moles of O2 is your final answer for that. All right, let's push on. I'm going to do this one and give you the answer to the last one, but not actually solve it. That's a boldface, so you do that one. Okay, hopefully this is becoming kind of routine by now. So how many grams of O2? So it's grams of O2 is what you're looking for. That goes way over here. Will be needed to produce 5.67 moles of H2O. So that goes way over here. Okay, so we'll go back to the organizer here and clean it up. Okay, so the first thing we have is 5.67 moles of H2O. So here's H2O, here's the moles row, so that's going to be 5.67. And what we're trying to find is grams of O2. Here's O2. Here's O2. You need to get down to grams, so that's your question mark there. So you're starting here. You need to go sideways inside the equation from here to here. We just did that one in the last part. And then now you need to go from moles of O2 through the molar mass of O2 to get the question mark. Okay? So let's go ahead and draw two boxes. Okay, there's the two conversions for this first one. Which one are you going to choose? Going from moles of H2O to moles of CO2. All right, you need moles of H2O to cancel, so you're going to choose this one. So moles of H2O cancels with moles of H2O. So now you're sitting in the moles of O2 box, that's right here, and you need to use the molar mass of O2 to come out. So we'll write that over here. Okay, there's your two conversion factors, your ratios. So which one is going to go in this box? Need moles of O2 to cancel out and grams of O2 to appear on the top for the final answer. So it's going to be this one. So moles of O2 cancels. The last units you have are grams of O2. So everything is set up. So multiply everything on the top. 5.67 times 3 times 32 divided by everything on the bottom, divided by 2, divided by 1, and that equals 272.16. Okay, and that's your answer for that. Okay, and let's go ahead and give you the answer to H. Just the answer, not the entire solution. You do that. Okay, and for the final problem, this one right here, H, there's the check figure answer, okay? But again, I'm not interested in the answer. I'm interested in seeing that you set these up and show your cancellations properly, okay? The answer is really of secondary importance at this point. Learn how to do stoichiometry properly. Okay, that will take care of this video, and that's problem 2, and problems 3 and 4 will be posted very soon.